Hi, everyone, and thanks for joining us for our cloud webinar series. We're going to give folks a few more minutes to hop on before we get started. Hello, all, and welcome to part 3 of Tevora's cloud webinar series. I'm Emily Paddock from Tevora's account management team. And today, Chris Callis, manager of our cloud practice, will take us through maintaining your security posture for governance in the cloud. If there are any questions, please use the chat function in the GoToMeeting, and we'll address them at the end of the presentation. So to kick this off, I'd like to iterate Tevora has been doing consulting work in the information and security risk and compliance space for 16 years. We have over 100 consultants on staff that specialize in enterprise risk assessments, pen testing, data privacy, solutions advisory and implementation, point-in-time security compliance frameworks, including ISO, SOC, PCI, HIPAA, and HITRUST, and of course, securing cloud workloads in AWS, Google Cloud, and Azure. With that being said, Chris, the floor is all yours.
Perfect. Thanks, Emily. Perfect. So today is part 3 of our webinar series called Governance in the Cloud, all about maintaining your security posture. If you've missed any of our previous webinar series, at the end of this presentation will be a link to our website where you could download those webinars and feel free to catch up. So as Emily was saying, Tevora is an information security consulting company that serial specializes in multiple verticals within the cybersecurity space. Compliance, if there's a 3 to 4 letter acronym, we could most likely certify against it. Solutions, it's the implementation of technologies. Threat, they do the pen testing, the red teaming, and the research. Incident response, this practice, they lead tabletop exercises, they respond to incidents. They are also a PFI, and what that means is if there's a card breach, the card brands have a narrow list of organizations that actually can go in and do the forensic investigation, and we recently, within this year, became one of those. So it's also pretty cool. So as we've been building out this cloud security practice, there's really 3 major risks that we identified as we've been really helping our clients build out their workloads over the last couple of years. Some of those risks are compliance uncertainty, misconfiguration, and environmental sprawl. From these risks, we put together a cloud security strategy that is broken out into 3 tenets: compliance, operations, and security. These are the 3 areas that need to be covered for a comprehensive cloud strategy. Compliance, this really ties back to what we spoke about earlier in our previous webinars in regards to DevSecOps. Yes.
The audience says the slides are not in full screen.
Let me see here, 1 second. Oh, I see what's going on. 1 second. This should be better. Thank you.
Looks good. Yep.
Everything look good? Perfect. All right, awesome. So what I was talking about is compliance. This really ties back to what we spoke about earlier in regards to DevSecOps. The dev portion is all about building it faster. The ops portion is all about keeping it stable. DevSecOps combines cultural philosophies, practices, and tools. Security should be tested as early as possible and not be treated like a bottleneck. If security and compliance teams do not have a seat at the table during architecture, security controls will be left out or not configured correctly. Operations, is the data and is its telemetry there? This translates to the confidence that the team has in their workload, allowing them to keep it stable and secure. And then security, are the security controls in place? Do teams have an understanding of their responsibilities to maintain security controls? Do these expectations align with compliance requirements? Have their run-in playbooks been updated to reflect the cloud? Have they performed resilience testing to ensure their procedures align with the current controls and their response capabilities? And are they able to demonstrate that they've been maintaining security and compliance standards throughout the year? So with that said, let's do a little bit of recap on some of the stuff that we've learned over the last couple of webinars. Webinar 1, reducing the attack surface. In our first webinar, we started at the basics. We explored the AWS console, common services used, and how they are frequently misconfigured. We then dove into some high-level best practices in terms of hardening an AWS environment and how to validate they are configured properly. The next webinar that we did was monitoring for compliance. We explored how to monitor for compliance and security in the cloud. We discussed our industry observations around compliance not evolving and still being a manual process, and how this translates to audit fatigue for compliance teams. And then we layered on our current understanding of common attack vectors. We evolved our knowledge and started to layer on security controls, such as Inspector and AWS Config, to help you maintain your security and compliance posture. We then dove a little bit into automation in our last webinar called Using Automation to Enforce Compliance. In this webinar, we built upon the same theme as we did in the previous webinars. We discussed a variety of ways to apply automation. We explored the limits of the default automation within tools like Inspector and Config. We learned how to chain services together, such as Lambda and SNS, to get a more granular control and reporting on exactly what we want. We discussed your organization's tolerance to automation, and if you want to treat it as a stopgate or have it automatically reverse changes. I then gave you a sneak peek on what we will be covering during the webinar today. So before we dive into the webinar today, let's talk about a little bit about environmental growth. Just like your production environments, our AWS environment has grown from a single VPC with a public subnet that we all manually configured together during that first session to an environment that we're going to be covering today that has public, private, and DMZ subnets with defined VPC ACLs, which limit the types of traffic and their origin into our environment. We have EC2 security groups that are leveraged to provide stateful inspection, which helps you meet compliance requirements. Automation has been implemented to prevent rule changes that deviate from our established baselines. Organizational approved AMIs are spun up in production in their appropriate subnets, and EC2 security groups. Most importantly, this has all been implemented as code, which provides us with a scalable, repeatable process to ensure uniformity. So for today, we're going to explore leveraging compliance as code or infrastructure as code to enforce security, allowing us to evolve our event-driven information security program. We're going to review the output of CloudFormation scripts and see how they translate to the production environment. We're going to test automation to ensure that it is working properly. We're then going to explore permissions by function and ways to limit the blast radius by placing guardrails on developers and web administrators, or really anybody that has access into the AWS console. And then we are going to explore technologies that support this, such as boundary permissions. But to start off, since we've been adopting this DevSecOps model, let's start by creating a couple of user stories. Security controls should be carefully worded to avoid ambiguity. So the first user story we have here is around network configuration. And in here I put, I'm a compliance manager, and I want only approved network configurations that are restricted to approved ports and protocols so that I can be assured that our environment will not fall out of compliance. And then story number 2, as a security manager, I want approved AMIs tagged and hardened by the security team to be allowed to start within a VPC, so that I can be assured that running EC2s are on the latest images and not vulnerable to any known exploits. Perfect. And with that said, let's start. So here, we're back within the AWS console. And what we're going to do here is just to make sure that we're starting with a clean slate before we provision the environment. We see the typical single VPC that is default. And we also saw that a couple of, we have the standard 6 subnets. Next, we're going to go to CloudFormation, and we're going to create a stack. I'm going to specify an S3 URL that I have the config that I put together for this presentation. But right here, we're going to specify the stack names. And under parameters, you can see that there's some predefined parameters that I put into my running config, such as the CIDR ranges, as well as ACL rule numbers. We're still going to, follow that initial user story and give our environment name webinar, and we'll see how that aligns with the user story that we created. I put in a notification email address, my work email, so I get notifications of any changes that go through, and this is a result of the Lambda function that's going to be caked into it. Right here, here's some notes that I have in the template that it creates a public DMZ with private and public subnets and a single availability zone. It deploys an internet gateway with a default route for the public subnets and a NAT gateway with default routes for the private subnets. Establishes VPC ACLs as well as EC2 security groups with some light restrictions placed in, and as well as creates a role for Lambda as well as a Lambda function that will roll back any type of EC2 security group changes that are made from this baseline. This is a nice area here for the output of the parameters. This is also specified within the running config itself. So I have for my own notes, private, public, DMZ subnet ranges, the rule numbers for the ACLs, and this could be used pretty well for evidence gathering. I'm also going to acknowledge that this CloudFormation script may create resources, such as the Lambda function role, during this process. So right here, it takes about 15 minutes to complete. And we're going to do another stack here in just a second. And this one's going to be to deploy our virtual machines within the environment. Again, I provided the S3 URL for accessing these scripts. We're going to give our stack name to align with our user story. And for the parameters, I have approved AMIs that developers can use. Today, we're going to do the T2 micro AMI. And then we're going to select the appropriate security groups and subnets for the DMZ public and private subnets themselves. We're going to select my SSH key for administrative access. We'll wrap this up here in just a second. Under configuration stack options, we're just going to leave this blank for right now. Again, we're going to review the deployment. So it lets us know EC2s are spun up and they're placed in the appropriate subnet and EC2 security group. There are some of the outputs from the running config itself, and we're going to click on Create Stack. So this will take about 10-15 minutes to do, and we'll come back and take a look at the results in just a moment. So here we are back in the AWS Management Console. Let's take a look at CloudFormation here to take a look at the outputs and the scripts that were ran. So if we take a look at the events here, we have an event tab, and this will confirm the successful creation of the various assets that you specify within your running config. We could see that the public route tables are created, the security groups, network ACLs, a couple more network configs here. And this is a good way to validate. When we were putting together this CloudFormation script, we had the option selected to roll back if anything actually failed. And what's really nice about this is once you have these scripts deployed, you could really just hit delete and it will return your AWS environment for the most part to its previous state, which is awesome for being able to replicate an actual environment, or if you wanted to spool things up like this into like landing zones or something like that, which is pretty neat to be able to do. You also have the capability using something like, instead of CloudFormation, you use something like Code Pipeline, or you could build in, you could use stuff with like Terraform. You could have your repo within GitHub, and then you could have essentially AWS monitor if there are any changes. So once you go through your change control processes and everything gets approved, you could have automation to automatically deploy systems to production, which is something important. Keeping people away from production, keeping people away from data prevents breaches. If these things are built and aligned with security best practices, a lot of the times, it's a developer, somebody that has overly permissive permissions that exist and allow them to deviate from the actual baseline. From the compliance perspective and just for organization in general, this is another quick sanity check that you can do from the Outputs tab. This is defined within the running config itself. So I can see the values for the subnets. I can see the values for the VPC itself. And what's important about this is, these values, depending if you're a pet versus cattle type shop, if you're restacking your VPCs, something like this is going to change constantly. You may have an auditor that comes in and they're reviewing, this EC2 that's deployed within your production environment, and these values may change. So this allows you to, one, keep a running record, and you could provide them with, hey, we did restack these between the last finding, and we could do X, Y, and Z to confirm that it's actually fixed right now. So now that we took a look at the output for the actual CloudFormation itself, let's take a look at what the scripts actually did. First thing we're going to do is we're going to take a look at the VPCs. And within the VPCs itself, you could see that there's now 2 and 9 subnets. You can see how the tagging helped out because it's going to put the name webinar there for me, which is great for organizing and knowing, exactly and referencing things, which is nice. Next thing we're going to dive into is the actual subnets. Again, you can see the same format: webinar, public subnet, private subnet, DMZ. Let's take a look at the public subnets. Some of the sanity checks that I like to do are, one, that it's attached to the correct VPC, that it has the right network ACLs. So we see it's apart from the webinar public network ACL, and it's also on the route table webinar public routes, which is what I wanted. When we take a look at the route tables, we could see that an internet gateway is attached, and we'll be taking in, 443 traffic, HTTPS traffic. So that's expected. So it can hit the internet, which is great. Then I have a couple of network ACLs that are here. So when these are the VPC ACLs. You could see them on the side over here under security. And with VPC ACLs, this is what the traffic first hits before it actually enters your environment. The issue with, not necessarily an issue with a VPC ACL as much as it is with the protocol, whether it's stateful or stateless protocols. VPC ACLs are a stateless firewall. So that's why you see things here where I allow 443 in, but I'm allowing response over ephemeral ports. Same with the outbound rules. When we take a look at the private subnet here, again, we could see it's tied to the private network ACLs. On the route table, I have it set to the webinar private routes as well. Again, it's tied to a NAT gateway versus the internet gateway, so there's not a route that actually goes to the internet. And this could be confirmed up here as well. You'll see, depending on the one that's set in, you could see it has a no for auto-assign public IPv4, which is good. Then when we take a look at the network ACLs, for right now it's just SSH, but we see the SSH is allowed from 10.0.10 CIDR ranges, which correlate to our DMZ subnet, which is where our Bastion host is going to be located. And then, if there's like a database or something in there, you would add a couple more rules to the EC2 security group layer itself. And then for the webinar DMZ subnet, again, we could see that it's attached to the right VPC, it's attached to the right network ACL. The route table is set to a public route just because this is where our Bastion host is going to be receiving traffic from. Again, confirming that it has access to the internet. And from a network ACL perspective, I allow SSH in from quad zeros. The quad zero should be really changed to, where your organization's administrative traffic comes in through. So just keep that in mind when you're putting these things together. Next, let's take a look at the actual security groups. What's nice about the security groups is, these are stateful. They do stateful inspection of the actual traffic that's coming through, which helps you meet compliance requirements as well. So let's start with the public security group. We can see inbound rules. We only allow HTTPS in. Since it is stateful, putting outbound rules, if it has an established connection, it's going to allow outbound traffic. That's why you really want to lock down, your VPC or your network ACLs to prevent that outbound traffic from actually coming out. If you take a look at the DMZ security group, again, we allow SSH in from quad zeros. That should definitely be your organization, where you guys allow administrative traffic to actually come in through. And HTTPS from our public subnet itself, which is, that's going to be where our reverse proxy is, hitting our actual web server within the DMZ. And then when it comes to the private security group, here these are a little more locked down, only allowing traffic from the DMZ subnet itself. So let's do something that maybe somebody with overly permissive roles should not be able to do. So from here, say for some reason we wanted to turn on SSH, and we wanted it from anywhere, but instead of it from our DMZ subnet, we're going to allow it to come in through the public subnet. And then for some reason on our DMZ subnet, let's just open this up to, for some reason, somebody wants to run a mail server. Anywhere. Perfect. So we'll come back and we'll take a look at these in just a little bit and see if our automation that we knew came in through our CloudFormation script is actually working. Next, what we're going to do is we're going to take a look at Lambda. This is kind of like the heart for the automation. So essentially, okay, to start off, from right here under the function name, we see webinar hyphen security group change auto response. Webinar comes from our actual script itself in labeling and tagging everything, which goes back to our user story itself. And the way that this actually works is, if there is a change to an EC2 security group, that's going to kick off a notification over SNS. And what's happening is this is monitoring for that notification, that particular notification, that if the monitored security groups are modified, to roll it back to its default state. So let's take a look here. And we're going to take a look at the configuration. I'm not going to bore you guys with the Python as much as I know you want to go through it. And essentially, there's a couple of environmental variables that are being called out here. We have security group ID 1, 2, and 3. And those correlate to our public, private, and DMZ subnets that we just reviewed. We also see ARN for SNS topic. And this is about CloudWatch events where essentially, EC2 security groups are modified to actually kick off this function. And the last and important thing is, there was a role that was created for Lambda to actually perform these duties essentially. And one of the roles that was given to it, or the policy for it, essentially says, you have the ability to revoke and then roll back essentially the EC2 security group. So that was all done through automation here. Now let's dive into identity and access management a little bit and take a look at what was provisioned. We take a look at the roles. Again, the role here, we could see, you have the webinar security group, and it's hyphened with webinar as according to our user story itself. And there's a couple of policies that are attached that have to do with the DMZ security group, private security group, and public security group modification. So these policies allow it to make the changes as needed when the changes actually roll in. And the last one I want to take a look at with you guys is EC2. So these are the virtual machines. They're going to be exposed or not exposed to the actual internet. Starting off with the public instance here, we could see that it's attached to the public security group, which is what we wanted. For inbound rules, it allows 443 to come in, which is great. It's using the organizational approved AMI, which is specified within our running config itself. Under VPC ID, we could see that it's on the webinar VPC, and it's also tied to the webinar public subnet. Same thing with DMZ. And same thing with the private security group, which is great. Next thing that I wanted to go over, now that we took a look at the output from some of the automations, we'll dive in here in just a minute to see, if the automation actually worked and roll back the function. But one of the things I wanted to talk about is boundary permissions. The concept is easy. It's to put up guardrails. You want to give your developers the ability to leverage resources as you see fit. You want to eliminate the need for them to wait for a central control team, or having compliance treated essentially, or security as essentially a bottleneck. And what you're really trying to prevent is get more granular access with these user roles. And you really want to avoid a star-star situation, which is pretty much like a super user within an AWS console. So in our AWS lab right here, under users, we could see web admin. And this is a situation, if you take a look at boundary permissions and the literature on it, it kind of works the other way. But generally, when we're going into an organization, what we're seeing is this. Somebody has root privileges, somebody is part of, somebody has domain admin when they don't need domain admin, or somebody in AWS has administrator access when they really don't need administrator access. And what I meant by star is if we took a look at the policy summary here, it's essentially allowing them to do anything. And just to kind of prove that a little bit, we're going to take a look at the policy simulator. And let's do something like cloud formation. And this policy simulator is horrible in some ways. So yeah, create stack instances, delete stack instances, delete stack, create stack, delete stack, create stack, all of these things. Let's do a simulation on what they can do. They can do all of these things. Okay, fun. All right, so now we go back and we know that they have full access to the actual account itself. What I did as part of the running config is I created a policy here. In that policy, if you go to filter them for customer managed policies, there's a permission boundary web admin. So what my organization did is we went in and we specified what type of permissions does a web administrator need. Well, this could get way more granular, but just as an example, it allows them to take actions against EC2 or S3, essentially. So they should be restricted from pretty much everything else. So what we're going to do here is we're going to go to the web admin. And under the permission policies right here, we have something called permission boundary. And we could set a boundary permission for the user. And if we select customer managed and we go to permission boundary, the policy that we just reviewed, and now when we look at web admin, we see that not only do they have administrator access, but the permission boundary is now actually applied. So what does this look like from a web admin perspective? Does the administrator have access override everything, or does the permission boundary take over? So let's take a look here. Our login is the web admin. The first thing that we tested before was we did simulated the policy against CloudFormation. So right away when we go into CloudFormation, we see that they're not able to perform the function list stacks, which is great because that means they can't go in and start deleting things. You also don't have the ability to create a stack. So say I'm the web admin and I want to adjust my actual permissions themselves because I know I have administrator access. I go into IAM, and even though I do have administrator access, it lets me know that this user doesn't have access to list anybody. We can't create a rules, we can't modify rules, we really can't do anything. The only thing that we can do is within EC2. You'll notice the EC2 doesn't give us the capability. It gives us the capability to launch instances, take down instances, do whatever we need. And you can get as granular as you'd like with this, but I just broke it down to the service level itself for right now. The other one that they had access to was S3. And again, they have the ability to create S3 buckets and do whatever they like. But then they're restricted from pretty much everything else within AWS. Take a look at Lambda functions. We're not authorized to perform these actions. And so this is a great way to start rolling back, permissions on people that may have just administrator access across the board, which is nice. So, you could sit down within the organization, you could granularly define what each role needs to do its actual job function and start bringing it back that way. So that's been something that we've been using a lot in a lot of the engagements that we've been working with our clients on. So let's log back out of web admin here. Let's log back into my administrative accounts. Good, the MFA worked. That's always good. And let's take a look at the EC2 security groups that we modified. So if we go back to security groups, webinar, right away, we could see inbound rule is back to 1. So we could see that the automation kicked off. We could also see that POP3 doesn't exist as well. So we could see that the automation kicked off. So essentially what happened was there was a CloudTrail that went out, that hit a CloudWatch alarm with a metric associated with it, which was being monitored by SNS, which then, once that got triggered, kicked off the Lambda function. The Lambda function has Python within it, essentially to say, hey, if you're monitoring these 3 security groups, make sure that they only follow X, Y, and Z rules, which were defined within the running config itself. And that's pretty much it. Those are 2 of the common ways that I see organizations use to enforce governance within the cloud. It's one thing to, having an event-driven information security program is great because you could focus on, the things that you actually want to focus on. These things about like boundary, you're not going to get inundated with, 1,000 ticket requests anymore if you're using things like boundary permissions because you're giving the developers the flexibility to do what they actually need to do without having you okay, as long as they live within the confines of what your organization is defined as necessary for their actual job role. Yeah, it's great. So back to the presentation here. So that's governance in the cloud. Again, my name is Christopher Callis. There's my Twitter. Something that I did for everybody on this webinar, feel free to share it, is there's a GitHub instance that I put up with a running config that essentially stands up, I think, a public VPC with a public subnet, and it has some security group rules attached to it, so you guys could play around with it, see how it works, and feel free to reach out, pick my brain if you guys want to chat cloud security. Always happy to do this. Again, check out our website here if you wanted to see our previous broadcasts as well as this one, and that's it for today. I'll go over to the questions here.
Yeah, we have some questions. Someone wrote, noticed you were using CloudFormation and not something like Terraform. Any advice on best ways to stay agnostic?
Yeah, that's a good question. So I was using just CloudFormation here, just because I didn't have Terraform spooled up on my actual system. I think it's important to stay agnostic. Definitely, a lot of the workloads that we review are within AWS. We're seeing Azure pick up a lot more as well. You want to stay agnostic. The thing is, whatever if you take a look at the development resources for AWS, it's going to tell you things like AWS, semicolon, semicolon, IAM, semicolon, semicolon, ID. It can only do certain things. So those would easily translate regardless if it's in CloudFormation or Terraform to AWS. You're just going to have to rewrite the stuff according to, whatever the Google or Azure development build is itself. But I think it's definitely important to try to stay as agnostic as possible. Just the output on CloudFormation here give us a little more detail that I wanted to demonstrate today.
Okay, and another question is, how do you test out the user story and explore tagging capabilities?
Yeah, so, we talked about this a little bit. Let's see if I still have it spooled up. So one of the ways that we can do it is if we take a look at CloudFormation. The issue with the CloudFormation side of the house is if you take a look at the outputs, a lot of these keys and stuff like that, those are only going to be tied if it's called out within the actual config itself. But you can also do something like AWS config. And AWS config acts as a good inventory type manager, which is great. And you should be able to pull up tags here. So when you're going through and you're doing like, here's my EC2 subnet. And when you start defining your rule, and you could take a look at our previous webinars, you could do those with tags. So you could have, is public, yes, is approved by security, yes, whatever, schema that you're using within your organization, you could define that in here. And you could start getting an idea of what exists with those tags and what doesn't. And then what you would do on top of that is, say that user story is, they shouldn't be able to spin up these EC2s within the environment. You could then bake in, a Lambda function. Essentially, it says, hey, if we see an EC2 spin up that doesn't have these tags or doesn't meet this approved AMI, just immediately shut it down. That's one way to approach it.
Perfect. And then regarding boundary permissions, why would we not just give them administrative access to begin with instead of layering on other controls?
Like prevent giving them administrator access, I think. Yeah, I mean, that would be good in a real world. But in the reviews that we've done, there's a lot of organizations that either don't restrict. Once you give somebody administrator or you start giving them the roles that they actually need for things, they just get overly permissive way too fast. And in our experience, there's more findings of, hey, this guy has root access, or this person has domain admin, or this person has administrator access with AWS than not. That's why we wanted to explore this functionality. You could go through and start stripping away their role. Some of it's an optics thing. They may initially be like, hey, I don't have this access anymore. What's going on? And then that'll open up a ticketing system. Where a boundary permission is a step up. It allows you to reign in control. That's why it's a nice process, because if they do have the ability to start granting themselves things within IAM itself, that's okay if they do it, if you give them permission to do it, but they still can only do it to the limits of the boundary, which is great. So it makes it a much easier way to demonstrate security and compliance when they're coming in and they're asking you, hey, is this the access that they need by function? And it's an easy way for you to prove that. That's one of the reasons. Perfect.
All right, looks like we don't have any other questions in, so.
Perfect, awesome. Well, you guys have my contact information. Any questions, feel free to reach out. It was great doing this with everybody, and talk to everybody soon.
Thanks everybody for joining.
Thank you.